Imagine receiving a letter filled with mathematical formulas so extraordinary that they appear to have been written by someone from another dimension. What you are about to discover is the story of a self-taught genius whose intuitive understanding of numbers defied all conventional education and left the greatest mathematicians of his time utterly speechless. In a small town in southern India, a young man with barely any formal training filled notebooks with theorems that would take the world's finest mathematical minds decades to fully comprehend. This is the remarkable tale of Srinivasa Ramanujan, a mathematician who saw numbers as living entities, who claimed his formulas came to him in dreams from a Hindu goddess, and whose brief but brilliant life changed mathematics forever. Born on December 22, 1887, in Erode, Tamil Nadu, Ramanujan grew up in humble circumstances, his family struggling with poverty in colonial India, where opportunities for education were limited for those without means. At age 10, he was already outperforming students years ahead of him in mathematics, and by age 12, he had mastered advanced trigonometry and was developing his own sophisticated theorems. His extraordinary talent caught the attention of his teachers, but Ramanujan's obsession with mathematics would soon become both his greatest strength and his most significant challenge. When he entered Government Arts College in Kumbakonam at age 16 on a scholarship, Ramanujan became so consumed by mathematical research that he neglected all his other subjects entirely. He failed his exams, lost his scholarship, and found himself without formal education or prospects, yet he continued to pursue mathematics with an intensity that bordered on obsession. During these years of struggle, Ramanujan filled notebook after notebook with thousands of formulas, theorems, and mathematical discoveries, working in complete isolation from the global mathematical community. If these stories of forgotten brilliance inspire you, subscribe to Hidden Minds and activate the notification bell to never miss the extraordinary tales of geniuses the world tried to forget. Visit the link in the description for additional resources about Ramanujan's mathematical contributions and other overlooked pioneers who transformed their fields. Without access to modern mathematical literature or university libraries, Ramanujan was essentially reinventing centuries of mathematical theory while simultaneously making discoveries that were completely original and unprecedented. His primary resource was a single outdated textbook, Synopsis of Elementary Results in Pure and Applied Mathematics by George Carr, which listed thousands of theorems but provided no proofs or explanations. From this bare-bones reference, Ramanujan taught himself to reconstruct proofs and then ventured far beyond, creating entirely new branches of mathematical theory that would astonish professional mathematicians. Working as a clerk at the Madras Port Trust to support himself and his family, Ramanujan spent every spare moment on mathematics, covering slate boards with calculations during lunch breaks and late into the night. His colleagues noticed his peculiar habit of writing endless formulas on any available surface, and some thought him eccentric or even mentally unstable, but a few recognized the potential genius in his work. In 1912, at the urging of friends who recognized his extraordinary abilities, Ramanujan began writing to prominent mathematicians in England, hoping someone would recognize the value of his discoveries. He sent letters to 3 mathematicians at Cambridge University, including Herbert Baker and Ernest Hobson, but received no response. his theorems likely dismissed as the work of a crank or fraud. Finally, in January 1913, Ramanujan wrote to Godfrey Harold Hardy, one of the preeminent mathematicians at Cambridge, enclosing 9 pages of his most remarkable mathematical formulas. Hardy later described receiving this letter as one of the most singular experiences of his life, saying the formulas must be true because no one would have the imagination to invent them. The theorems Ramanujan included were so extraordinary that Hardy initially suspected fraud, thinking someone was playing an elaborate joke, but upon closer examination realized he was witnessing genuine genius. Some of Ramanujan's formulas were already known, some were wrong, but many were completely new and utterly baffling, presenting results that Hardy and his colleague John Littlewood could neither prove nor disprove. Hardy recognized that these formulas could only have come from a mathematician of the highest caliber, someone with an intuitive grasp of number theory that seemed almost supernatural. After months of correspondence and overcoming significant obstacles, including Ramanujan's religious objections to crossing the ocean, arrangements were made for him to come to Cambridge, England in 1914. The contrast between Ramanujan's life in India and the rarefied academic atmosphere of Cambridge could not have been more stark, and the culture shock proved profound and challenging. As a devout Hindu and strict vegetarian, Ramanujan struggled with the English climate, the food, and the isolation from his cultural and spiritual roots, factors that would contribute to serious health problems. Despite these difficulties, his collaboration with Hardy proved extraordinarily fruitful, producing papers on partition theory, infinite series, and continued fractions that revolutionized several areas of mathematics. Hardy was amazed by Ramanujan's intuitive methods, which bypassed conventional proofs and seemed to arrive at truth through some mysterious direct perception of mathematical reality. Ramanujan claimed that the goddess Namagiri would appear to him in dreams and reveal mathematical formulas, which he would write down upon waking without any formal derivation or proof. Hardy, a committed atheist and rigorous formalist, found this mystical approach both fascinating and frustrating, often spending weeks trying to prove results that Ramanujan simply knew were true. One of their most significant collaborations involved the partition function, which counts the number of ways a positive integer can be expressed as a sum of positive integers. Ramanujan and Hardy developed asymptotic formulas for the partition function that were accurate to an astonishing degree, work that laid foundations for modern analytic number theory. Ramanujan's notebooks, particularly his work on Mach theta functions which he developed near the end of his life, contained mathematics so advanced that their full implications weren't understood until decades later. In 1918, Ramanujan was elected a Fellow of the Royal Society, one of the highest honours in British science, becoming the second Indian to receive this distinction at the age of just 30. That same year, he became the first Indian elected as a Fellow of Trinity College, Cambridge, a remarkable achievement for someone who had arrived in England just 4 years earlier with no formal degree. However, these triumphs were overshadowed by Ramanujan's deteriorating health, as the English climate, dietary difficulties, and possibly tuberculosis took a severe toll on his physical condition. Some historians suggest he may have suffered from vitamin deficiency due to the difficulty of maintaining his vegetarian diet in wartime England, compounding his health problems. By 1917, Ramanujan was frequently hospitalized, spending long periods in sanatoriums where he continued to work on mathematics despite his illness. Even while seriously ill, confined to bed and knowing his time was limited, Ramanujan's mathematical creativity remained undiminished, and he continued to make groundbreaking discoveries. His final notebook, known as the Lost Notebook, was filled with formulas on Mach theta functions that would baffle mathematicians for more than 50 years after his death. In February 1919, his health failing rapidly, Ramanujan returned to India, hoping the familiar climate and surroundings might aid his recovery, but the damage was irreversible. He died on April 26, 1920, at the age of just 32, leaving behind 3 notebooks filled with approximately 3,000 theorems, many still unproven. Hardy, devastated by the loss of his friend and collaborator, later said that working with Ramanujan was the singular romantic incident of his life, and rated Ramanujan's natural mathematical ability as comparable to the legendary Euler and Jacobi. For decades after Ramanujan's death, mathematicians continued to mine his notebooks, finding results that anticipated discoveries in physics, computer science, and advanced mathematics that wouldn't be fully developed until the late 20th century. In 1976, mathematician George Andrews discovered a sheaf of papers in a box at Trinity College, Cambridge, containing more than 600 formulas in Ramanujan's handwriting that had never been published. This lost notebook, as it came to be known, contained work on Mach theta functions and Q-series that opened entirely new areas of mathematical research and continues to yield insights today. Modern mathematicians using computer algorithms have verified many of Ramanujan's formulas that were too complex to prove by hand, consistently finding them to be correct. His work has found unexpected applications in string theory, quantum physics, and cryptography, fields that didn't exist during his lifetime but that rely on the mathematical structures he intuited. The famous Hardy-Ramanujan number, 1729, emerged from a touching story where Hardy visited the ill Ramanujan and mentioned arriving in taxi number 1729, calling it rather dull. Ramanujan immediately responded that it was actually a very interesting number, being the smallest number expressible as the sum of 2 cubes in 2 different ways, demonstrating his extraordinary numerical intuition. Ramanujan's story raises profound questions about the nature of mathematical talent, genius, and the role of formal education in nurturing or potentially suppressing extraordinary abilities. Had he received proper mathematical training earlier, would his contributions have been even greater, or would formal methods have constrained the intuitive leaps that made his work so revolutionary? The circumstances of his life highlight how many brilliant minds throughout history may have gone unrecognized due to poverty, lack of access to education, or the barriers of colonialism and social inequality. India now celebrates National Mathematics Day on December 22, Ramanujan's birthday, honoring his legacy and inspiring new generations of mathematicians. Numerous institutions bear his name, including the Ramanujan Institute for Advanced Study in Mathematics at the University of Madras and the Ramanujan Prize for Young Mathematicians from Developing Countries. His life has inspired books, films, and countless students who see in his story proof that genius can emerge from anywhere and overcome seemingly insurmountable obstacles. Contemporary mathematicians continue to explore his notebooks, and papers are still being published that elaborate on theorems Ramanujan wrote down more than a century ago without proof or explanation. The fact that a self-taught clerk from colonial India could revolutionize mathematics demonstrates that brilliance knows no boundaries of nationality, class, or formal credentials. Ramanujan's work reminds us that mathematical truth exists independently of human discovery, waiting to be perceived by minds capable of seeing patterns invisible to others. His intuitive approach, guided by what he described as divine inspiration, produced results that rigorous formal methods took decades to verify, suggesting multiple paths to mathematical truth. The tragedy of Ramanujan is not just his early death, but the tantalizing question of what further discoveries died with him, what formulas remained unwritten in his final days. Every time modern technology relies on number theory, every time physicists use partition functions in quantum mechanics, they build upon foundations this forgotten genius established in isolation and poverty. The man who saw infinity in numbers, who conversed with a goddess about mathematics, who shocked the greatest minds at Cambridge, deserves to be remembered not as a footnote but as one of history's most extraordinary mathematical minds.